Okay, let's see how this works today. For some reason, all the options were a little bit different today. Okay, so first thing I'm going to do is go over the quizzes again. Not that many people turned them in early, but the few that were turned in were very good because let's face it, they just weren't that hard. So the first question was to draw a graph with 5 vertices of degrees 1, 1, 2, 2, and 4. So probably the easiest way to do the problem is just put your 5 vertices, but don't put them on a line. When you put them on a line, it doesn't feel like you have as many options, even though it's correct. So I just say, kind of make them around a polygon. Now, if I want 1, okay, that guy's got his 1, so he's done. I don't want any more leaving that guy. So maybe I'll have this guy be a 1 as well. Now I need a couple of 2s. Great. So those guys are now 2s. Oh, but darn, I need a 4. Right now I have 1, 1, 2, 2, 2. How can I get a 4? Anybody? Because you guys did this.
Can you just do a circle on the 4th one? Or a loop? Yeah.
A loop on which one? Or does it matter?
The one.
Well,
yeah, right.
Actually,
anyone with 2 degrees.
I do a loop on any of the ones that have degree 2. Let's say I do it on this one. Oh, okay. Now I still have my 2, 2. I have my 4. So the ones that are 1s can't connect to something else. The ones that are 2s, it's easy to make into a 4. So this would be an example of one. Is it the only one? No. I could have put the loop on any of the 3. Is that the only way I could have done it? Could I have done it by making multiple paths? No, because then it would have made both of them 4. So that's why this is probably the best answer. Now, the second problem said 3, 3, and 6. Okay, well, I probably should connect them all to each other. All right. Now what? How do I make 3? I'm 2, 2, and 2 right now. So how can I get 3? Do I make multiple loops on everything? Or multiple extra ones, or
You can draw another edge between 2 points.
See, if I do a loop, I'll jump from 2 to 4. And I don't want to do that. Now, I could wipe one of these out. By the way, I could do this and put a loop here, put a loop here, and then what? Okay, this, I don't think anybody turned in this one. Is that legal, what I just did? Does that work?
It's legal.
Yeah, it's probably not the one that any of you did. I think most of you thought of a more obvious pattern. You said, okay, there's my 2. I like what you said. I'm going to have another path there. Okay, there's my 3 and my 3. I now need to go from 2 to 6. Probably something like that, I'm guessing, is what most people did. But the fact is, there's more than one way I can do this. And that's the important thing, that you realize you can do this more than one way. Now, the next problem, we want to draw K 4, 4, which just simply means I'm going to do this. Okay, and then I'm going to connect all the possible ways. Now, a lot of you will go all around. You're going to do everything you can to avoid crossing. Doesn't matter if I cross. Crossing doesn't change something from being an edge. In other words, this is totally okay to do that. Okay. What I'm not going is sideways. That's the one thing I cannot do. Let's see, and I think I got that one. So you're going, okay, my eyes are blurred. Well, I'm taking these 4 and I am matching them to these 4. So exactly how many edges did I just draw? That's easy. How many edges? You don't have to count them.
16.
You're 16 because you matched 4 with 4. That's how you know. Because if I did, just in general, if I said this, how many edges would there be?
M times N.
M times N. That's critical that we recognize that, because otherwise you're sitting going 1, 2, 3. It's too much work. Now, the second half of the question said, what is the degree of the graph? There are 16 edges. What's the degree? Is
32.
Yeah, the inflection at the end makes it sound like they're not certain. Why is it 32?
Because there's 2 points for each edge, and they have a degree
Each
each.
edge, good. Each edge is connected to 2 vertices. So each vertex gets to count that edge in its own individual degree. Another easy way to think about it is look at each vertex. Aren't there 4 edges coming out of every vertex? So every vertex in my picture clearly has degree 4, and I have 8 vertices. That's why the degree is 32. Or I like the idea that one edge connects 2 vertices, so every edge is going to count for a degree 2 because it's counting at each end. And that's very, very important. Now, the last question, I changed this question over time. I used to ask this question with fewer people, and I found the answers got kind of silly when I did it that way. So I decided to make it a lot of people. Okay, this comes from the section called the handshake problem. Some of you probably saw this. Essentially, it's this. If every single person in the class, let's say we all lined up in a big circle, and then we on the floor drew line segments, edges to every other person in the class, we know exactly how many edges would be drawn. We also know what would be the total degree, and we know that total degree has to be even. So essentially, you're saying you have 49 people. Can you have 8 edges coming out of each person? Is that possible? That's really what the question is asking. If you have 49, so you have 49 vertices, and each person has 8 friends. So each person is connected to 8 other vertices. Is that actually possible? What I used to do is I'd ask the question with maybe 6 or 8, and then people would be drawing pictures, these massive pictures, and saying yes or no based on their ability to draw the picture, which is a terrible idea, because when they couldn't figure out the picture, they'd say no. Saying I don't know how to find the answer, therefore there's no solution, is not a very good way of doing math. So can anybody tell me why it is or is not possible on number 4?
There is a theorem in the book that says yes.
But why? Why?
Well, then I have to read how to prove.
Oh, no, it's simple. There's 49 vertices. Each person's a vertex and each other person's a vertex. So basically I'm saying, can I have 8 friends? Is there a way for me to draw 8 edges from my vertex? Again, you have 49 people standing in a circle.
Yeah, why not? You can draw.
Why do you know it is possible? Because 49
times 8 is
times
even.
8 is even. That's it. That's it. It doesn't matter how large the numbers is. It's just basically even. So therefore, tell me about number 5. The same 49 people, can every one of them have exactly 9 friends?
No,
No,
because 49 times 9 is 441.
That's odd, and that would mean the total degree of your graph is odd. So I could have 48 people have 9 friends, but that 49th person better have an even number of friends, right? It won't work. Mathematically, it's impossible because it would mean my total graph has odd degree. That's it. The no picture necessary. I used to have people always trying to answer both questions with a picture. Again, your ability or inability to draw a picture shouldn't determine whether you can answer the question. This comes from that theorem called the handshake problem. So it's actually a fairly simple notion. So it doesn't matter how many people I have. It's all about odd or even. And it goes back to the degree question. So now the second quiz, that's quiz 25, excuse me. Sorry. G is a connected graph with vertices of degree 2, 2, 4, 4, and 6. Does G have an Euler circuit? Now, what a lot of people did was they tried to draw an Euler circuit, and if they were successful, they said yes. So what if you were unsuccessful? Does that mean it's no? Again, your ability to draw the picture or not draw the picture has nothing to do with the answer. If you say, well, I don't know how to draw this picture, so the answer's got to be a no. That's not a good answer. No. Does the graph have an Euler circuit? I'm not even going to draw it because there's many, many, many possible graphs. And by the way, if you wanted to draw the graph, okay. I'm going to go ahead and draw this graph. All right, everybody's got 2. I need a couple of 4s. How am I going to get a 4? Well, I can go across, or I could do something like this. Now that guy's got 4, but now that guy's got 3. So, okay, now that guy's got 4. Okay, but that guy's got 3, so this is not working yet, is it? So I'm trying to draw the graph. And by the way, I could eventually figure out the graph. But do I have to draw the graph? Or do you already know the answer to the question? Because this was.
I mean, if you have one vertex with degree with odd degree, then you cannot do it.
So it's an if and only if, by the way. So is the answer, does a graph, if you drew this graph and you made those vertices work, a lot of you would think I'll just do loops and things. That's fine.
If all vertices even, then you can, yes.
Because every vertex is even, the answer is yes, period. See, if I start trying to draw it and I struggle with the drawing, that can't determine my answer just because I can't figure out a graph. No, all my vertices have even degrees. So the answer is yes. So the answer to number 2 is I have 1, 2, 2, 3, 4, and 4. There is definitely a legal graph there because the sum is even, but every individual vertex is not even, which would mean that I'd have to retrace my steps at some point. That's really what it means. That's the 7 bridges of Kronosberg question as well. So the answer to 1 is yes. The answer to 2 is no, because in 1, all the degrees are even, and 2, I have odd degrees. Okay. Now, I want to draw a graph with 4 vertices and a bridge. I'll do this. Let's see. Did I give you anything else? 4 vertices. Okay. Let's start simple. Okay. There. Okay. So V1, V2, V3, V4. I'm going to start simple. E1, E2, E3. Is this a connected graph with a bridge?
Yes.
How many bridges?
3.
There are
1.
3 bridges.
Oh.
Ooh, there are 3, because if I removed any of the 3, it would no longer be connected. See, most of you are looking and you're saying E2 is my bridge. You're right, E2 is a bridge. But if I remove E3, then V4 is now on an island all by itself. There's no way to get to it. Oh, okay. So I could make it more fun and more complicated. Can you make a situation where E2 is the only bridge? Can anybody tell me how I can make this so E2 is the only bridge?
You can
Connect E.
I lost it. I can do what?
So I can connect V2 and V4 with another edge.
I can go, okay, good. I like that. Now is E3 a bridge?
No.
E1 is still a bridge though, isn't it?
Yes.
That will work, but then but then you say, well, what if I connect these 2? But then I can remove that one. So there's actually an easier way. How about if I just go like that? Would that work?
Yep.
Now I've got E5 and can't count, E4 and E5. And if I remove either E4 or E5, it really won't make any difference, but removing E2 still. So basically you drew a picture where if I remove an edge, it's no longer connected. And there's an infinite number of pictures because I could keep doing all sorts of, heck, I could have loops, I could do all sorts of things. But the fact that this bridge from this city to this city, here was the bridge joining them, and it was the only way to get there, that makes that a bridge. Okay, and now the last one, let's see, draw a graph with 6 vertices that is not connected. Now, clearly there's an infinite number. 6 vertices that's not connected. I'm going to do the most uninteresting graph you could possibly imagine. Okay, I'm done. Did I accomplish my goal? A graph with 6 vertices that is not connected? Would that work?
Yes.
Yeah, I have no edges. That's really boring, but it's possible. Oh, okay. All right. So now that got kind of silly. Okay, how about that one? I have a graph with 6 vertices that's not connected. Will that work?
Checks out.
As long as I have 2 separate parts that don't agree. So think of it this way. Take the last problem. Wherever you identified there was a bridge, so create a problem with exactly 1 bridge and then remove that bridge. That's probably the easiest way of thinking about this. Create a problem. So I could do, this and this and, I'm going to go there. I'm going to go there. I have all sorts of fun. but these are two disconnected graphs still, as long as I don't connect them. Now, if I create a bridge here, it's now a connected graph. That's it. Yeah, that's pretty easy. Now, the last one, draw a connected graph having 8 vertices and at least 2 Euler circuits. Now, I believe we did this. I did exactly this graph unintentionally, I think, during the lecture. Okay. You don't necessarily have to number them, just make your vertices really clear. So probably going to start, like this. All right. Well, do I have an Euler circuit?
Yes.
Yeah, if I can start at any vertex and just go around the horn and I'm done. That was okay, that was easy enough. But I only have 1. I need 2 or more. By the way, I said it has at least 2. You could have lots more than 2. What's another way I could get multiple Euler circuits? I'll give you a hint. If I did that and that.
I have a question here.
Yes.
So even if you have, like you said, only 1, but if you go to a different direction, vice versa, it doesn't count as the second one?
Oh, changing your direction, is that?
Yeah.
Because you're still, yeah, technically, but it's the same sequence in reverse. So it does that blade, like I'm picking up my graph and rotating it. So it's still the same, it's essentially the same path. Okay, I'm starting by connecting things opposite. This now has degree 4, but this now has degree 3. So what if I, do something like this? Oh, sorry, I'm sorry, too many already. Okay, now that has 4. And right now I have 3 vertices of degree 1, 2, 3, 4, and all the rest have degree 2. Is it possible now that I've just created a scenario that has a second Euler circuit?
Yes.
Let's say I start here. Boom, 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 boom. Ooh. I got a different Euler circuit, didn't I? So what most of you did, because I saw Sergey's, I think he did things like this, just create that extra one. I did something like that in class. If I do that all the way around, that will work perfectly. And then it's sort of like inner loop, outer loop. Absolutely correct. There is no unique answer. You just have to create a situation where you have 8 vertices and every vertex has even degree, but all of your degrees cannot be 2. Because if all of your degrees are 2, then you only have the 1 Euler circuit. Okay, so we're just messing around creating a second case. And the few that were turned in early, I was able to look at before the test. And there weren't that many, but I was able to look at them. Most people interpreted this very, very well. Now, I want to spend just a minute talking about the exam, because there was a couple of problems that people were confused on, saying, why did I miss these or lose credit? Well, on this exam, what made it kind of easy is for every problem, there was exactly one solution. There were no variations. There were no, well, I could have interpreted it a different way. No, because most of them were calculations. But there was one problem. Well, actually, there were 2 problems. And I thought it was very interesting. There were a couple of problems that a few people did completely incorrectly, but got a right numerical answer. And they're like, well, why did I get credit? I'll give you an example. On problem 17, because a right answer is not a right solution. The answer is the last thing you wrote. The solution is the whole thing. It doesn't matter if the answer is correct if the solution isn't. I had a few pigeonhole principle questions where the person answered the right words, yes or no, but their reason was completely wrong and in fact contradicted their yes and no. It was completely whack, but they go, but I got yes, and the answer was yes, but you actually gave a reason that was a no. So on number 17, for example, we asked for the probability of getting at least 8 tails. And most people did this one pretty well. They said my numerator is this, and then my denominator was this. This was a correct answer, and that gave 56 over 1,024. That's it. It really wasn't that exciting of a problem. But I actually had some solutions where a person looked at the problem completely differently. I'm flipping one coin 10 times. So 10 has got to be in there somewhere. I had somebody tell me the numerator was the permutation of 8 choose 2, which makes absolutely no sense. Where did the 8 and 2 come from? I'm flipping one coin 10 times, and I want to get 8, 9, or 10 results. So I have to add 3 things together. This is completely whack, doesn't make any sense whatsoever. Oh, by the way, gives the exact same numerical answer. So does that make it a valid answer? No, that's just sheer dumb luck. In general, you can't make a permutation equal a sum of combinations. It actually was only true for this combination of numbers. This was a completely wrong answer, yet it still gave the same numerical solution. Again, that doesn't make it valid. So there was another problem that a lot of people struggled on, and I gave a tremendous amount of partial credit on, let me find it, hold on a second. Why can't I find it? Hold on. It was a card. Oh, it's because there's more pages. Hold on a second. Here we go. It was problems 13 and 14. I gave a lot of partial credit, but there were a lot of incorrect solutions, but I got the right numerical answer. Actually, every part of the problem was incorrect, but we got lucky because of the numbers. On problems 13 and 14, we have 52 cards, and you're going to grab 3 cards at one time. Is this a permutation or a combination if I'm grabbing 3 cards at one time? Am I putting them in order or am I not putting them in order if I'm grabbing 3 cards at one time? It's
No order.
no order, so it's a combination. My sample space is 52, choose 3. That's it. I'm grabbing 3 cards at one time. Putting them in order would make your sample space 3 factorial times bigger than it actually is. The sample space is 52, choose 3 for both questions. That's your denominator on both questions. If I said pick 1 card at a time, look at it, set it down, pick 1 card, look at it, set it down, we've done that problem as well. That would be a permutation. Totally different answer. That would be a 52 times 51 times 50 denominator. This is a combination. I'm grabbing 3 at once, so rearranging them isn't a different outcome. 1 at a time, rearranging them is a different outcome. So the denominator is 52, choose 3 in both cases. Now, my numerator, I'm going to grab 3 cards at one time. How many ways can I do that? So my numerator in both problems is a combination. So in both problems, numerator and denominator are combinations. But if I do a permutation, that means I made both my numerator and denominator 3 factorial times bigger than it actually should be. But I made both of them off by the exact same multiplier, which is why the multiplier cancels and I get the right numerical answer at the end. So a lot of people got the right numerical answer with a wrong numerator and a wrong denominator. They just happen to be wrong exactly the same amount. That doesn't make it a valid solution, but I gave a lot of partial credit on that. I actually gave 20 out of 30. Technically, it's 0 out of 30. You have a quotient where both numerator and denominator are incorrect. You can't get a full credit answer because we misinterpreted permutation combination twice. Back when I used to teach algebra, and we're at the beginning when we're learning how to multiply negatives and things like that, I would have students make multiple errors on the negative signs. But as long as they made exactly an even number of errors, they got the right answer. If they made an odd number of errors, then they got the opposite sign of the right answer because you're multiplying negative ones on things. Because I got the right answer doesn't validate what I did if I've made multiple errors, but I made it, as long as I made an even number of errors, I was going to be okay. No, those were the only problems where we got sidetracked. Overall, though, most people did a very good job. There were some problems that stumped some folks, but the fact is there were so many to choose from that most people, found enough problems that they could do. Now, we have a final exam tomorrow. Okay. The final exam, of course, is everything in the course, including the graphs, but the graphs are not going to dominate the final. That's going to be a question or two on the final. Okay. It's not going to be more. Now, if you think about it, we had 25 lectures. So here's how I want you to envision the final. If you could say, let me take the single most important thing we learned that day. What if you could characterize the entire lecture in one question? So maybe on the last quiz, it might be the Euler circuit. Maybe that's the most important question you say for that day. If you could summarize every single lecture with just one question, then that's what's going to go on the final exam. Big ticket items, not detail. not minutia. So if we're doing proofs, exactly that one type of proof, it might be a proof by induction, one proof by induction. It might be an element proof, but only one. There won't be two of anything. I can ask you multiple questions on the individual exams because they were only over 7 or 8 lectures. The final's over 25 lectures. So basically it's like one question from each lecture. And the stuff at the end, of course, is on the final, but it's not going to be heavily weighted. It's going to be worth the same as everything else. So just because we never got tested on the last 2 lectures doesn't mean the last 2 lectures, are going to make up 50% of the final. No, they'll make up roughly the same percentage as everything else will. So that's how the final is structured. Again, if you've turned in the last 2 quizzes, that would definitely help your cause. And most of them are probably going to be pretty good. Right now on Canvas, those scores are not there, not yet. So if you're trying to make an informed choice, until I post those last numbers, you don't know exactly, but you probably have a pretty good idea how you did. I mean, that's not a great mystery. So in the course, I want to remind you, there were 2,550 points possible. Well, with all the bonus and the extra credit questions, there's probably, I don't know, maybe closer to 200 more points than that possible, but we'll start with that. So 90% of that.
29.95.
Oh, you've already got it. I was going to multiply it out.
I just remember because I was looking at it.
So there's the threshold for an A. Okay, but what is it for a B? I don't memorize these.
That one I don't know.
40 is the threshold for a B, and I think it's 1734. Now, what that means is when you go to Canvas and you go all the way to the right where it has your percentage, if you put the cursor over your percentage, it will actually give you the quotient. Hopefully everybody knows it. It'll actually give you the quotient that produced that. And right now that quotient probably has a denominator of 2490 because the last 2 quizzes have not been posted. So don't go purely by your percentage. No. Go by the total points. If you have reached any of these thresholds at this point in the game, you are absolutely guaranteed that grade. What if you've reached one of the thresholds, but you are less than 60 points? But I threw a bonus, so really it's like 72 points. But let's say you're 30 points from the next grade, but you did do those last 2 quizzes. Well, then those last 2 quizzes will probably bump you over. And I will have those posted this afternoon, I promise. I'm just finishing up the 151 exams, and then I will get to our quizzes, before the end. I don't want the day to go too long. Most of you, again, have a good feel for that. Then you'd know. Now, let's suppose that you're right in the middle. You're in the middle of the C range, or in the middle of the B range, and you're not going to get an A or a B based on your quizzes. But turning in those quizzes still bumped your quiz grade up. So here's how the final grade is figured. If you decide I don't want to take the final, then you get a 0 on the final, but the weight of the final is exactly the number of points being dropped. The final exam is worth 750 points. That's what's being dropped. But if you say, I want to raise my grade, well, then you're going to have to take the final, and the final will replace the lowest exam plus the 5 lowest quizzes if the final is better than those scores. If the final isn't better than those scores, then the final is still the drop grade. So if the final is terrible or you choose not to take it, then the final is not counting. The final has to be better than the scores it's replacing. Again, it's replacing the lowest exam plus the 5 lowest quizzes. So if you've already made the grade and you're happy with your grade, you don't need to take the final. If you said, I want to take the final because I want the feedback. I want to know, what did I retain? Well, again, the final still can't hurt you. Final can only raise your grade. It can't lower your grade, because if it's lower than the other scores, then the final's the thing that's dropped. Okay, so it's a win-win, but only if you're prepared for the final. Now, again, whether you choose to take the final or not, that's your choice. What I would like, though, is an email. So if you said, no, I will take my grade, I'm fine. Whether that's an A, B, or a C, you say, I'll take my grade. Just send me an email saying, I'm not going to take the final. The reason is the day of the final, I'm looking and seeing who's showed up. And if I've got 5 or 6 people that I'm expecting, now I'm emailing them, I'm trying to find them. I'm watching the police blotter. I'm listening for ambulances. I'm worried. I'm a parent. I start getting worried. I'm like, I was expecting Sergey to be there and he's not there. Again, if you choose not to take the final, it's fine. Just let me know. I assume everybody is taking it unless they tell me otherwise. Now, in terms of what you can bring, yes, you can bring all 3 of your 3x5 note cards, but I think you're better off starting from scratch, because as we know, it's the creation of the formula card, not the existence. It's me writing down those theorems and definitions and things that I'm going to benefit by. Therefore, you may use an entire 8.5 by 11 one side. So if you actually want to do the mathematics, 3 3x5 cards, both sides, that area is about the same as one side of one sheet of paper. But the reason I want to do this is I really would rather you start over. Again, that reinforces things. Plus, there are things you wrote down that you may not feel the need to write down again. And there may be things you left off that you should have written down. And now you go, no, I'm going to make sure that makes it to the sheet. So one side of an 8.5 by 11, you know, you can get a lot of information on there. I can't imagine you would actually fill it up, but you could. And I had somebody actually print all of the things they thought were necessary, and then they shrunk them down. That's always a wise one. And then they put it on their formula cards. Well, you could do that for the sheet. Part of your preparation, of course, would be to prepare. Any calculator is fair game, because there's no advantage based on the calculator. Now, last logistical thing, this is a final exam. You can't, 85 minutes is not enough time to take any final exam in any class. So I always give you 2 full hours. But because I give another final right after, our final exam will begin at 7:45 and go till 9:45. Then I have time to get the next class started just a few minutes later. You will have 2 full hours to take a final. On campus, I do the exact same thing. I usually teach my 3-unit classes at 8 a.m. so I can start earlier. We'll actually start way earlier because there's always another class waiting to come in. In our case, in our class, it's not the case. I can't go till 10 because the other class will already be on Zoom by then. So this is the time. Like always, I will email everybody the exam 10 minutes or so before this. That's when we will physically start. And then you got the same rules as always. Now, in terms of the final exam grade, okay, that I will have to email you. Canvas does not have the ability to have the final exam grades on there and then the total course grades. The final exam is the only part that won't show up on the Canvas scores. So you know where you are. And the other thing is Canvas, there's no dropped scores. That's kind of up to you. So when you're looking at your overall scores, you can scroll through there and say, okay, which are my worst quiz? Which is my worst exam? That's really not that difficult. So if you're trying to figure out, okay, what do I need on the final? Well, again, you're going to count your 20 best quizzes. You're going to count your 2 best exams. The easiest way to do that is find your worst scores and subtract them from your current total. Then you know exactly how many points you need on the final. And if that's doable, you got to take the final. Okay. Now, if you say, it's a 750 point final, I need 1,600 points on my final to raise my grade. Well, that's probably not going to happen. But if I need 80% on the final to raise my grade, or I need 75%, that's very doable. Okay. And I expect to have the finals done certainly before the end of the weekend, because I want to be done. My summer is over when I click submit on the grades. So just like always, I'm in a hurry to get it done. Now, does anybody have any questions whatsoever? I'm going to keep.
Just a small question to confirm, because I'm looking at the syllabus, and there is a section it's called incomplete, which says
that nobody in this class is eligible for an incomplete.
Yeah. I just want to ask, because it says if you cannot make the final, then it will be incomplete.
No. An incomplete is a person who has already passed the course, but for some other reason cannot physically take the final exam. They're eligible for incomplete. They're eligible. The district really, really discourages incompletes at this point for many, many, many reasons. Mostly it's because it's paperwork, and because I don't know what the percentage is, but I know it's somewhere in the 90+% range. Students never actually complete their incomplete.
I see.
So therefore, in one calendar year, their grades automatically converted to an F by the registrar. I've had incompletes, emergencies occurred, things like that. And a person needed the final to get through the class.
Okay.
But if you're saying, well, if I miss the final, does that an incomplete? No. that's a person who was going to take, who had to take the final in order to. So if you've already earned a letter grade, you can opt out of the final. You're just saying, I'm going to take a 0 on the final. Incomplete means you actually have to come back and complete the course at a later date.
Okay, thank you. Yeah, I just didn't know the rules of this.
And it used to be easier, but they decided to make it difficult because they found out that they created too many loopholes. But I would have situations where quite literally the day of the final was rolling around and somebody had an emergency. I mean, a legitimate emergency. And so what I do is I'd say, okay, I have to turn in my grades, but I will file an incomplete, and then maybe next month or in a couple of weeks, we'll come back and we'll finish it. That, you know, and then I can submit the grade change. That used to be the way we went. They made that situation virtually impossible. Now they say, no, that student just has to take a 0. They've decided that somebody's going to determine the legitimacy of you missing it, which I think is wrong. I think it's always should be up to the instructor to determine, you know. So if, again, an emergency happens beyond your control that physically prevents you from taking the final exam, but the other things, you actually had to be passing the course. A failing student can't get an incomplete, and you can't get an incomplete for partial. That was the other thing. Some people some instructors were giving out incompletes, you know, when a student halfway through the course couldn't complete it. No, that's a withdrawal. No, an incomplete means in our class, you would have had to do enough. In other words, take at least 2 exams, because one can be dropped. Anything short of that would not be eligible for an incomplete. But there's nobody in our class that's eligible, because nobody in our class is in that position. So it's something I have to include, you know, but
Yeah.
I have not given an incomplete in over 10 years. It just hasn't come up. So it's a non-issue.
Yes, thank you. I just want to confirm because
Yeah.
sure.
Yeah, you're okay, Sergey. Tom, what day is it?
I'm so close, 2 days.
Well, the nice thing is I think you won't have to take 2 finals, probably.
Yeah,
You probably-
that's what I'm banking on.
And I think, you know, I think personally, you put yourself in a very good situation. For those who don't know, Tom had to take back-to-back exams yesterday. That was part of the conditions of his parole. I said, you should have gone for the orange jumpsuit, picking up trash on the side of the freeway.
No, I agree.
But yeah, you did something that most people would say you're completely insane, but I tell you what, in another 25 hours from now, you're going to be rejoicing. So
I did the math. I know what I need on the final exam for this class.
and it's totally doable. It's totally doable.
Absolutely. I actually just had a question regarding so there's no practice final exam though for
your practice final, basically think of it as like you have 3 exams and 3 practice tests, as well as 25 quizzes. You have, in a normal semester, very few people could actually get through all of that unless they started weeks ahead of time, you know, going over things. So you have more practice material than you could even imagine. So for me to come up with more questions, I'd just be borrowing from those questions anyway. So the best way to prepare for any final is always retake old material that you have a key for. I think it's a waste of time to practice any problem where you can't immediately check to see if you did it right. That's why I tell people, when you're doing problems in the textbook, for our book, always do the ones that are highlighted, because those are the ones that have the full solutions. Because if you're doing the other ones, you might be right, but you're basically saying, I hope I'm right. I don't know, because I can't check my answer. And I just don't think that's extremely valuable. In this case here, I don't think anybody needs to review exam 3. You just had it yesterday, but you might need to review exam 1 because it's been a while and we haven't been doing any of those types of problems in a little while. So that's why you just kind of go through and say, okay, I got this. But also for the purposes of making your formula sheet, because you've got to identify, oh, you know what, I need to make some of these, you know, some of your equivalents, you know, logic relations and you know, just a few things, just reminding you what's a conditional versus a converse, you know, versus the other things, things that you have known, but you said, you know what, I want to make sure I have absolute clarity during the final, because during a final, you know, stress and things, we sometimes forget really obvious things. That's why you need to write some of the things down. You know, I think things like logic facts were not things that people knew coming in. And so those might not be set in stone. Something as simple as, again, we've done this before. If I'll keep the simplest case. then what's the converse? What's the contrapositive? What's the inverse? What's the negation? Those are the things we tend to struggle with if this is the conditional. And I don't need an example, right? So what's the inverse? The inverse is this. Oh, so then when we're asking is something, what kind of error is it? A converse error or an inverse error? I have to remember what the words mean. And most people are doing really well on most of these, but you'd like to be 100%. Again, certainty is a really good thing. Now, this is basically just open office hours right now. So I'm going to stop the recording.